Yes, hey, welcome back. Now let us solve the problem here presents, which is problem of the day of number second. And yeah, like you are given an unsorted array and a number k, which is smaller than the size of the array, and you have to return true if it contains any duplicate within k distance, or else you have to return false. And there is an important bit of information over here, that is k is smaller than the size of the array. This is very important, like because if k was not smaller than length of the array, then we have to make some additional modification. Like yeah, if by any chance k was greater than length of array, then like we could just check if k is greater than length of array, and if that was true, then we could always return true, because yeah, it was again not necessarily that we could always return true, but if the k was greater than length of array, then we have to iterate through the array and check if any duplicate exists, and if that existed, then we could return true. But since k is smaller than length of the array, we have to do some additional modifications that like to solve the question. Like, but given that k is always smaller than size of the array, so let's not worry about that, and we have to return true if it contains any duplicates within k distance. So what does it mean? Like, take this 1 2 3 4 1, and we take from 1 and check the next three steps. You see 2 3 4, and no duplicates. You take 2 next three steps, and you don't see another 2. You take 3 next three steps, you don't see a 3, so on. That's why you return true. Like yeah, that's why you return false, because there are no duplicates. But you take this one over here, and you take one and take the next three steps. You can see that one is already there. That means that there is a duplicate in k distance, and so you have to return true. So how can you solve this? Like, this is kind of a sliding window approach. So what we'll do is that we'll have a hash set. Like if you see the expected complexity, yeah, the auxiliary space is okay because we actually need that. So what we can do is that we can have a rolling dictionary. So what it will do is that it will keep the track of element at the current index, and it will remove the element at the index I'm like current index minus k. You have to just do that. So for example, first you will keep a track of window of these three elements, and then you'll keep a track of window of these three elements, and then you'll keep track of window of these three elements, and so on. And in that window, if a duplicate exists, that means that there is a duplicate in there or not. Yeah, the algorithm is that simple. So first, what we'll do for I in range k, what we will do, we'll have a dictionary. If by any chance I AR at the position I like exists in k, that means within the first k elements only there are duplicates. That means we will obviously return true. Or else what we'll do, AR at the position I, D at the position AR at the position I, we will make it 1. You can also have a set for this, it does not make any difference. So now what you will do? So now you have to check the next k window. So for I in range k to the last part, which is little bit length of array. So what you will do now? First, you have to check if by any chance here at the position I exists in D. That means that there is a duplicate within the in the given k window. So return true. Or else what you will do? You have to increment and shrink your window. Like, so what you will do? Error at the position I, D at the position, error at the position I is equal to 1. In other words, you're adding the current element to the window, and you have to delete the element at the position I minus k. So you will delete the element at the position, D at the position, AR at the position I minus k. And after everything happens, if nothing is returned, that means there was no duplicates. So return false. Let's just compile it once. Okay. If we are at the position I exists in k, this makes no sense. It has to be D. And this is and you see the question works, the solution works, and that's all what you do. You just keep track of current window, and to the current window, you remove or add element depending upon your window size kit. And yeah, the time complexity is O of n, because we have to iterate through all the elements of the array, and the space complexity is O of k, because your dictionary at any given instance, the maximum size will be k. Yeah, that's all for it, and thank you for watching.